and larger, well, what's the other direction? It must be less than 3 in the other direction. And similarly, if we had a number line here and it's, whether it's 10, if we go the other direction, left, well, then the alternative is everything else on that number line. It's to the right. So this is just something to sort of memorize. It's not really mathy. It's just something to memorize.
Okay.
Now, typically, this is like one of those gray zone areas of math and statistics. Typically, your claim, the thing that you want to prove, is the alternative.
Okay.
So in this problem, do you want to prove that it is not equal to 8%, less than 8%, or greater than 8%? And it's all based on that last sentence there.
If the figure is too high, so if it's more than 8%?
So what would the person like to, like the result of this is that they want to go out there and say that, no, the figure is actually, what would they say? Less than 8%, greater than 8%, or not equal to 8%?
That it's equal to 8%?
So they think it's too high. That's the key word there.
Okay.
So they want to come out and say that it's actually less than 8%. That's the claim that they want to make. Like imagine someone said, Julia, your swimming time for this run is 125 seconds. And you're like, no, that's too high. That's too high. What would you like to prove, or what would you like to claim it to be?
That it was lower.
It was lower. You're like, I'm not that slow. I'm fast. I'm faster than that. So your claim, or what you're trying to prove, is this side. And if you can figure out one or the other, you match it up to the one. So in this case, we want to say that the alternative is P is, sorry, it's just P. P is less than 0.08, which means that the null is greater than or equal to 0.08. And that's based on this right here.
Okay.
All right, so let me see if I can find some more problems like that, because it really is a big deal to be able to just write the null and alternative hypothesis.
Okay.
All right, this isn't the greatest example, but is it okay if I kind of diverge from the things you sent? We'll come back to it.
Yeah.
Okay. All right. All right, so a school principal claims that the seniors in high school have a mean SAT score of 1100. Okay. Now, this one kind of violates what I just said, which is typically the claim is in the right. Okay. But when you read the language here, when it says have a mean score, like the principal's saying, like, you will have a mean score of this. Okay, so they're saying like it will be 1100. Okay, so because it's a mean, we know that it's mu in both cases.
Okay.
Is what, can you tell me what symbol goes in one or the other? And keep in mind the claim is here, which is very different. It's kind of awkward, but that is what it is.
So if the claim is in
So think of it this way. If you and I, we want to come in and we want to prove that it was different than this. So the claim isn't necessarily what, I probably haven't worded this correctly. This is probably, I see why this is confusing. So there's a mixture of language. Let me just give it to you. This is that it equals 1100.
Okay.
And what we would like to prove, if we were doing some experiment, we would like to prove that it's something different than this, which is what this says here.
Okay.
Let's try it. Let's try another one here. Maybe this will be better. All right. The school principal wants to test if it is true that the juniors use the computer for schoolwork less than 70% of the time. So this is what they want to prove. And the prove typically always goes in the alternative hypothesis.
Okay.
So this is a P and a P. Can you tell me either of these?
Um, um, the claim is less than 70%.
So the way your book is doing it and the way I'm seeing here is that they put the claim and the prove. Maybe that's not the right word. It's more like suspicion, I guess, is maybe a better, and that's not a great word. Let me give you the answer again. So the suspicion is that it's less than 0.7. So you tend to believe, like, the claim would be that it actually is greater than or equal to 0.7. Let's look at some different examples. These are not written well, and I can see now why this is so unclear. Okay, let's look at another problem here. Okay, teenage mothers, according to a U.S. Census Bureau, 10.5% of registered births in the United States in 2007 were due to teenage mothers. A sociologist believes that this percentage has increased since then. That's the word you want to focus in on. That's going to tell you what your alternative hypothesis is. If it's increased, which math symbol are we using?
Greater than?
Yeah. So it's something greater than what? Now, we know it's increased. We're trying to prove that it's bigger than this number, 10.5, right here. And we actually don't know if it's a proportion or not. So I don't want to get hung up on that, but let's just use P. What would H0 be in this case?
It would be less than or equal to.
Yes. Yes. Okay. Could you try to verbalize what you're struggling with? Because I think I could kind of sense it, but I'm not completely sure what it is that.
I'm just kind of confused on the I'm starting to get it, but I don't really know, like, the HA and the HO, like, I'm kind of confused, like, what that stands for.
Okay, that's good. Good place to start. So the null hypothesis, null means 0, and that's why it's H0.
Okay.
Alternative is usually referred to as the research hypothesis or the research question. Usually. So they use a subscript of A. Now, some books use H0 and H1, which may be less clear. I don't know. But the idea is like, there's something that's like accepted to be true.
Mm-hmm.
Okay. And someone comes along and says like, I think it's changed. I think it's changed. Okay. So you're looking for those keywords, like the word changed could mean that it goes up or down. And that's why they use not equal to for changed.
Okay.
If they say, or they think something has increased, obviously that means it's gone up. That's where we think it's now greater than. Decreased means it went down. That's where it's a less than.
Okay.
Now, this is kind of the standard stuff. This is like 80% of the time. There are tons of exceptions that could come up. But it's kind of a keyword search. It's kind of a, like in the last problem, see, it said the sociologist thought that this percentage has increased. Well, that's how we knew it was a greater than.
Okay.
But for example, like when you swim, if you get faster or you increase your performance, that actually means it went down. So
Mm-hmm.
occasionally there's kind of these opposites of what you think it should be. Is that okay?
Yeah.
Okay. And it looks like you're doing two types of problems. You're either doing the one where it's mu and mu. This is for a sample mean. Or you're doing the one on a population P and P. I'm sorry, not population, a proportion. Sorry. Any questions on that before we do another couple of examples here to write the hypothesis?
It's starting to make sense. Yeah.
Okay. All right. So I want you to take a look at this and try to write one or the other, either the null or the alternative for me. How are you doing on this one?
Um. The alternative one is, what is that symbol called for the sample mean?
It's mu, or the Greek letter, the U with a little tail. Well, I don't know if you're a cat or dog person, but little tail there. Mu.
Okay, so I got for HA, I got mu less than 218,600.
Okay. And the key word there is decreased.
Yes. And then does that mean the original one is mu greater than
Or equal to. Yes, it has.
greater than equal to?
Yes.
Okay.
So not to make this even more confusing, but there are some books and some teachers that always make the null an equal to, but it does not appear that you are doing that in this class.
Okay.
Okay, so here's another one to take a look at.
Um, for the original, oh, for the null hypothesis, I got P is greater than or equal to 32.
Yeah, so it's mu this time because it's on a. So you only use P when it's a percentage or a proportion.
Oh, okay.
But yeah, okay, sorry, I took away from what you were saying. But it is important. If you use the wrong letter, it's also wrong. You see that in some pretty difficult classes. So 32. And then what's the alternative?
It's mu is less than 32.
Okay, and the key word here is underfilling the jars, underfilling.
Okay.
All right, here's another one for you to look at. Is this helping?
Yes.
Okay. And this is the basis of all scientific research, especially in political science. You make some sort of a claim that you think something has changed.
Oh, okay.
All right, so give this one a try, same thing. How are you doing on this one?
Is this one equal to and not equal to?
Yes. Now there's a second part here, which is which number is it equal to or not equal to?
Is it the 17,000?
Yes. And that keyword there is has changed. Has changed.
Okay.
So in real life, though, we don't, it's rare when we don't have some idea of what's happened. Like if you haven't seen someone in a long time and you're like, wow, you know, you look so good. You're like, we're usually like saying, you know, something has changed about you, but we're usually implying like a positive or, you know, in some cases a negative. But in
Mhm.
statistical terms, they don't care whether it's better or worse. Okay. So the only like analogies that might work, there are products and things that we do that actually go up or down depending on you know, time of the year. I mean, that's kind of a different class, but just so you know, because I mean, I think you're owed an explanation here. We usually know whether it's getting better or worse, but changed is kind of a, if you really don't have any idea, like it's, if it's exploratory research, you might say we think it's changed for that.
Okay.
So let's do one more here before we move on to a new topic. Some of these are very negative, but that's just the nature of this sort of statistical testing.
Is it, for the null hypothesis, is it P is less than or equal to 19.6%?
Yes. Now it would probably go to like 0.196. I don't know how your teacher is doing this. You generally don't use percentages in real life, especially when you're doing the math. Yeah. What is the keyword there for this?
Um,
How do you know it's either less than or equal to or greater than? There's a keyword in here, so a couple of places.
well, so for the, in the second sentence, it says, um, the 6 to 11-year-olds who are overweight is higher.
Yeah, overweight and then higher. Because it you got to be careful here. It's not that it's the overweight, it's that they think that it's gone up.
Yeah.
Although they tend to like they're not trying to confuse you in this problem, but just be aware that there are some weird exceptions that could happen here. Okay, so we made this table earlier just to kind of solidify it. H0, HA, and then we can actually draw, and we should draw a distribution here. So let's say it's equal to and not equal to. Here's what the distribution looks like. You end up getting two tails.
Mhm.
Two tail. You probably saw that in your notes.
Yeah.
If it's greater than or equal to and the alternative is less than, this is what is called a left tail, or one tail, but it's a left tail. Notice it's in the direction of the alternative. And then if it's less than or equal to or greater than, it's right tail.
Okay.
Now, just a few things that could be a little bit awkward here. The following are left-tailed, even though they may not look like it. The first one is kind of it's exactly what I did in the previous, up above. That's left-tailed, but so is this. This is also left-tailed. It's basically shading left. Is
Okay.
that clear? Okay.
Yeah.
And then same thing with right tail. There's kind of the one that we like, which is okay, there, it's everything to the right of that. That's great. But it could also be that you're way over here and you're still shading everything to the right. You're shading right.
Okay.
Okay. And that always, always, always comes from the alternative. The shading comes from the alternative hypothesis. Okay. So like when
Okay.
we go back and look at this, is this one right-tailed or left-tailed?
Um.
That symbol there. See if I can get it all framed in here. Can't quite get it all in there. Kind of.
Um. That one is left-tailed.
You're looking at this right here. This right here. So it matches up.
Oh, right-tailed.
All right. So this is right-tailed. Might even be a good idea. This is two-tailed. Oops, I don't know why I let it's an equal to two-tailed. This one is left-tailed. Right. You go back. You can go back and look at those if you want. Okay, so let's do some problems here. What's your favorite race? Swimming race event type?
The 100-yard breaststroke.
Okay. And what's a like a good average time for you?
A minute and 5 seconds.
Okay, so 65 seconds, we'll say. All right, so let's say H0 is well, let's do this here. Let's have you do it. This will be better. HA. Have you been training really hard lately or not so hard lately?
I would say pretty hard.
All right, so do you have reason to believe that maybe you are faster than that with some training? Like, let's say you did some really intense training. Would you think that you would now be faster?
Yeah.
Okay, so what does that mean for the alternative compared to 65?
That means it is.
What
Oh,
do you hope to prove?
so if you're getting faster, that's decreasing
Yes,
the
very
time.
good,
Okay.
very good. And this would be greater than or equal to. All right. Okay, is that okay?
Yeah.
Is this which tail is this? One tail, two tail, left tail, right tail? What can you tell me about this?
This is left-tailed.
Left tail, good, very good. All right, so now let's say someone comes along and they are able to do it in 60 seconds, okay? And we know that the standard deviation is 2, okay? What is the test statistic? Okay, so the test statistic here is Z. Do you remember there's a formula for Z?
I don't. Oh, is it X bar minus null hypothesis over standard deviation?
Yes, better written as X bar minus mu over sigma.
Okay.
Can you calculate that for the given value that we have?
Is it negative 2.5?
Yes. Yes, you seem a little uncertain. Is there anything you want to ask or anything you're?
It's just kind of confusing why it's a negative number.
Let's talk about that. On the normal curve, when it's standardized, it has a mean of 0. The center number is 0.
Okay.
Okay. So this is like Z's along here. These are Z's. All right. Now think about the numbers here. The population mean is 65. I know it's your time, but just forget about that for a moment. And the sample mean is 60. Is the sample mean above or below the population?
It's below.
So below means it's going to be left. So specifically, we'll just say that's minus 2.5. Okay. Now to decide which side we're going to shade, it's based on this right here. Which side are we going to shade?
Zach,
Left.
shut up.
You okay?
Yes. This is too loud. Jack.
Okay. So what I was asking here is you to tell me which side you're going to shade based on this symbol right here. It's always from the alternative, which the left or the right.
All right. It's too loud. Okay.
Do you need me to repeat the question?
Yes, please.
Sure. No problem. So again, this is our Z value. Did that totally correct. And the question is, where are we going to shade left of it or right of it? And it's based on this right here, this inequality, the less than.
Okay.
So if we go back up here and look, we said when it was less than, we shade to the left. Okay. So you might even write that up here. You might even write, oh, it's left. So we're going to shade to the left.
Okay.
All right. Now, do you have your TI 8384 handy?
Yes.
Could you do a normal distribution for this one and get the area? We were doing that last time. It's under second vars, I think, distribution. If you need me to, I can try and show you.
Is it normal EDF, right?
Yeah, CDF. CDF.
DDF. Okay. Um, And then what do you put in for the X value?
Minus 2.5. What do you have there? X, mu, and sigma?
Yes.
Okay, so your X is minus 2.5. Your mu is 0 and your sigma is 1. So whenever you're using Z, you want to think of it as your calculated Z. Mu is always 0 and sigma is always 1. So go ahead and calculate that. I've got the result as well, using something different, but it should give us the same result.
I got 0.0175.
One of us is not right. Did you do left-tailed on yours? Do you have to specify like left?
It doesn't show that up. Oh, okay, here we go. Let's um
And did you use CDF number 2?
yes. But now it says lower, upper.
Yes, that's what I was looking. That's what you wanted. Okay, maybe that's why I wasn't sure what you were using. Okay, so your lower is 10 to the minus minus 10 to the minus, sorry, minus 10 to the 99. Your upper is minus 2.5, and your mean is 0, and your standard deviation is 1. Okay, yeah, I was able to confirm that does work. You're using normal CDF, like you just said, upper, or I'm sorry, I got these in reverse. Maybe that's why it's not working. It's lower and then upper on your calculator.
Okay.
You can just always tell me if I'm way off, because I'm trying here to calculate it and then show you how to calculate it. It's sometimes not seamless. You should get 0.0062.
Yes.
Okay, make sure you are comfortable with that. But we're going to do another example here at least.
Okay.
All right, so let's say, I don't know, I don't have a very interesting scenario here, but let's just say mu and mu here, and our claim is that it's greater than 120. What would be the less than or equal to? It would be less than 100, less than or equal to 120 for the null here. All right, and let's say you went out and you sampled and you found that it was 150 with a sigma of 15.
Okay.
Could you tell me the Z value, please?
The Z value is 2.
Okay. So again, you were asking here before, it's like, all right, well, where is that? So 0 is right in the middle. okay, when it's normalized, is our piece of information above or below the mean?
It's above.
Above, so we expect it to be to the right. That's why it's positive. So let's say 2 is about there. Are we shading to the right of 2 or the left of 2 based on this right here?
To the left.
It's based on the alternative hypothesis. So see how on the previous one it was less than, so we shaded left.
Hmm.
In this one it's greater than, so we're going to shade to the
Oh, to the right.
right. Now this time when you go to your calculator, you got to do the lower, the upper. The lower now is 2. Think of the lower as the leftmost number and the upper as the rightmost number. The upper is your 10 to the 99. Mu is 0 and sigma is 1. Will you go ahead and calculate that for us, please?
Yes. Is it 0.022?
Yes, 7, 0.02, 0.0228, I guess, for rounding. All right. All right, so last problem here. Let's say we think that the mean temperature in the month of March is 72 degrees. And we want to know if it has changed. Okay. So we take the data and we find out that X bar is 69.5, and we know that sigma is 1. All right. Will you calculate the Z value for us, please?
Negative 2.5.
Negative 2.5. Very good. Now on the curve this time, because it's two-tailed, you put the negative 2.5 here, but then you also have to put a positive 2.5, and that's all because it's two-tailed. Okay, so you have to find the area of both of these. Now, because of symmetry, you only have to find the area of one. All right, so in a previous problem, we found that the area was 0.0062 in one. So you double it to get the total area. So you get the area of the one left, and then you would double it to get the total area of the left and the right. So in this case, it's 0.0124.
Okay.
Both. Okay. All right. So we do have to stop here. As much as I love this subject, I also love my sleep. So let me stop recording